Yeah, before we start, we actually decided to show you a bit about the toolchain we used for creating the presentation. So we did it in AsciiDoc, which is a markup language for creating very neat-looking documentation and any kind of content actually. It's a bit nicer than Markdown, if you ask me. So there is a bit of stuff which you need to install on your machine. So obviously what we did, we used Docker. So that's what we're going to show you. So we can actually say Docker build, and then I have this magical folder. So everything is cached, so I don't rely on internet now. But now what I can say is that I can want to start my container with the AsciiDoc toolchain underneath. And if I go to my other tab, you can see on the top there is a Docker container running. So we are hopefully ready to serve the presentation. So what's gonna happen now is this whole toolchain is actually running exposed to my host, and I can generate this stuff. And I'm a bit of a risky guy who likes risk, so I don't use on stage with speakers notes. I always use mirroring. So let's give it a try. Okay, so welcome everyone again. This is a talk about taming microservices testing with Docker and Arquillian Cube. It's a bit off shift. I don't know why it's like this, but nevertheless, okay, I'm just gonna move it slightly. Responsive design for the win, huh? Anyway, we're gonna stick to this. So
my name is Knutsen. I'm the Arquillian project lead and a senior software engineer at Red Hat.
And my name is Majsak. I work in Switzerland for Cambridge Technology Partners. I'm quite a long-time committer for JBoss projects, mainly Arquillian. And yeah, I'm a bit paranoid. I have a bit different Twitter handle than GitHub, but yeah, I'm gonna fix it for the next time. Okay, so before we dive into world of Arquillian and testing and all the cool things we have in the universe, let's just lay the ground a bit and talk about microservices. This is not a talk about microservices, but I thought it's gonna be good just to have a small recap. So what is a microservice? Microservice is a small autonomous piece of software which runs kind of, you can think about it like a similar to Linux process. So it's isolated, and basically you build your software with microservices so that they communicate with each other. So one can actually ask, so what actually means the service is micro? Should we measure it in lines of code, or should it be some other measurement? So I think the good rule of thumb for microservice is that it can be rewritten within a reasonable time, so let's say 2 weeks. So if we think about microservices, this I guess are like 4 most important principles which are behind this not so new movement, but it's quite, at least the term, it's quite new and it's getting a lot of traction. So first of all, it's single responsibility principle, which means that your service does one thing and does it good. Then the other aspect is that the services should be loosely coupled, which in this realm means that if you change something in one microservice, the other things shouldn't be really affected. The next important principle, which actually comes from domain-driven design, is a so-called bounded context, which effectively means that if you have a large system, you slice it to smaller concepts, and then they can have some unified model, which some of it is exposed, some of it is internal, but it's some sort of unification. And obviously, we deploy them independently. One good quote, which is maybe not the best quote in terms of sentence, it's a bit long, but that's from Uncle Bob, so Robert C. Martin, is that single responsibility principle, which is an essence for me for microservices, means more or less that you gather things which are changing for the same reason together, and all the other you separate because they are changing for different reasons. So with all these things, let's think for a moment, what are the benefits? So first of all, benefits of microservices is that they are simple. They are focused on simplicity, so as I said before, they do one thing, but they do it good. Then the other thing is, which is very interesting from developer standpoint, is that it lets us experiment. We can try different languages, we can try different platforms, and that's actually the real beauty of our profession, that we can constantly learn. And since microservices are fairly simple, they are probably easy to maintain. They also favor composition. So I put this snippet for a reason, because it's actually pretty much the same concept which is with us on Linux for quite a long time. You have small tools which you combine together, and you can achieve some more sophisticated things. For example, you can kill Eclipse, which is hanging for quite a while. And then the last thing, which is also very important, is performance and scalability. Okay, so we have microservices. We can try to ship them, but then the question is, what should be the environment for it? And here's another very interesting and very popular technology, if you look at the agenda of DevNation, for example, which are containers, so Docker. What it gives us in terms of microservices, it's not only that it lets us scale and deploy autonomously, but it also gives us a very safe environment, meaning that in contrast to monolith, where part of your system starts failing, basically everything else is falling apart. And if we have misbehaving microservice, we can basically kill it and restart the machine on the fly. So yeah, that's where Docker comes to play. And just as a short introduction, Docker is what I like to call a lightweight VM, which is actually the container engine running on top of Linux kernel with an asterisk here saying that there will be a Docker for Windows pretty soon, and probably for macOS. And it's isolated in terms that it has its own process space and network interfaces. So it's a very good fit for microservices, or in general for any kind of development. I remember when it was like maybe 5 years ago, I was working on built infrastructure, and back then Docker was at least officially not around. But what we had to deal with was we had the software which we had to test in several different configurations. So that was Tomcat running with Postgres on Ubuntu. That was the same application running on EAP with MySQL and so on. So you can see that the matrix is getting a bit complicated. So what we chose as a technology of choice was a virtual machine. And that was quite painful to maintain and to evolve the setup. Whereas with Docker, with images and all the layers on the way, this is actually fairly easy. And on top of that, they are immutable by default. So you don't, when you run your build within this kind of environment, you are not concerned about the side effects, because the next time you start it, it will start from scratch. So how to build a Docker image? So the first way of doing it is through Dockerfile. There is also another tool which is called Docker Compose. And there you define your dependent containers using YAML. And what you can also do, you can just pull any image from the Docker hub or from any other repository, do some changes on the fly, and then commit, which will result with the new image. So let's have a look at the short example. We have a base image, which is quite stripped Ubuntu. It's only 200 megabytes. And then what we do, we want to, within the container, we want to create the directory, which then we set as our working directory. Then we copy some file into it. We expose the port. And the last line is probably the shortest web server code you will ever see. And if you have single page applications, which are pretty much on the client side, that's all what you need. It's nothing else. OK, so let's have a look how it behaves. So I have here my Docker image, Docker file, which I can show you. It's exactly the same. What I can do, I can just say, I think it's run. So what it does, it just builds the Docker file, builds the image, and then I can actually show you what it's doing. So that's my web server with just an embedded image. It took me a while because I had to encode it in base64 and so on, but pretty much does the job. And that's pretty much it when it comes to the introduction for Docker and microservices. And now we're going to talk about Arquillian. So I hand over to Aslak.
Right. So how many here know what Arquillian is? Hands up. How many use it? Okay, so most of you should know at least the basics of how we're going to run, but just to kind of get people up to speed somewhat. Arquillian is a testing, it's not a testing framework, it's a middleware for your tests more than anything else. It's just trying to take a lot of the grunt work and repeating work out of your own test infrastructure and then provide you with hooks for running containers and starting containers and deploying and doing all those kind of management stuff. So Arquillian is built upon what we consider the Arquillian core, which is a tiny event machine essentially. And there's extensions upon extensions upon extensions. So there's extensions for different test frameworks. So there's JUnit, TestNG, JBehave, Spock, and a few others in the works. And then there's the container extension, which handles different container implementations. So you can control Tomcat, Wildfly, EAP, WebLogic, WebSphere, whatever you want essentially. And when you combine those all together, you get a container-controlled lifecycle within your test. And as far as how it's done in the background, in Arquillian, the first step is you select some kind of container that you want to run on. And when then Arquillian starts up as part of the test suite lifecycle, it will then start or connect to that container that you defined. In this case, we say we're going to run against the Wildfly server. And then when you come into the test class level, there is a deployment that needs to happen. And that's when you define the environment that you want to have this test to run in. And that's using a project called Shrinkwrap to add up all packages and classes and files and libraries and whatnot that you want this application or this test to run within. And then Arquillian on its own adds some extra stuff and deploys this deployment to the container. And then from within the container, Arquillian then forwards the test execution from the client to the inside of the container. And when you're in there and running, you have access to everything the container has. So you can inject things like the security manager, transactional manager, entity manager, and so on. And the test case behaves like the underlying component framework, for instance, that you're using. And then when Arquillian is running those tests, it will then capture the results and return them back through the client chain. So whether you're running from Eclipse or you're running it from Maven, Surefire or Eclipse sees it as just a local test, but it's actually been forwarded and potentially running on some completely different server somewhere. Then, of course, it does the undeploy and the cleanup to leave you with a known state, per se. If we look at this, would be a simple kind of skeleton for a JUnit-based test in Arquillian. It starts off with the first run with Arquillian, which is the extension point in JUnit, telling JUnit essentially to hand over the execution or the control over the execution of this test to the Arquillian runner. Then the special thing comes in with that deployment method. So in the before class event within Arquillian, which is triggered by JUnit, we execute this deployment method and get the archive that's there. That could be, in this case, we're just deploying a job archive, but it could be a web archive, a enterprise archive, resource adapters, or just a generic archive of some sort, depending on what type of archive the target container that we are running it against. And then when we come into the actual test execution, there's kind of two phases to it. In this scenario, we're running with the in container. So when you click Run as JUnit test in Eclipse and come to the test execution, that's not actually happening in Eclipse anymore. That's being forwarded to the deployment that has happened on the container, and now the test method itself is like you can call it a callable, essentially, that's being forwarded to somewhere else. And beyond that, well, of course, when that happens, we're also doing the injection. So in this case, we're using a inject of a CDI bean that is the live actual CDI bean that is deployed within the container. And similar, you could inject resources or EGBs and then get access to things like the entity manager or queues or whatnot. And beyond that, you just assert on the state as you normally would, and those results will be handled back. And then there's the other run mode, per se. So we have the in-container mode, where everything is executing inside that container. And then we have the client-side testing, which will be normally more targeted towards REST endpoints or remote EGBs or just web pages, where the execution actually is happening within Eclipse. So we're now setting up a deployment should not be testable. It's testable false, meaning that Arquillian will not do anything besides take that archive that is created there, the web archive, and deploy it. But since Arquillian has control over the deployment and knows about the container and so on, we also know where and what we have been deploying. So we can now start to inject things like the Arquillian resource URL, which is the base URL to that deployment. So you don't necessarily need to know which different target servers you have, or have some property files defining what is the URL of this app and so on. And in this case, we're using the REST assured framework on the client side to invoke the REST service that we have deployed and assert on the state of it. So as far as configuring and getting Arquillian up and running in your project, we have something called the Arquillian BOM, the bill of material, which essentially defines a bunch of different versions into one coherent bundle or stack. And in Maven, you can use that through the dependency management section and kind of override all the different versions. Gradle, through this Spring BOM support, has a similar feature. Or you could use it just directly with Anton-Ivy as well. There's no need necessarily to use Maven, though I would recommend to use at least some kind of dependency management system, just to make it easier on yourself. As long as you have that, then you define which test framework do you want to run with. And here we're just adding a reference to the JUnit container version of it. And by that, you have all the different base or core things that Arquillian need to get started. But as the first step is, you need to select what kind of container you want to run against. So here we have defined the Wildfire Arquillian managed container. So containers normally come in 3 different types. It's the embedded one, which will normally run within the same JVM as the Eclipse process or the test process, just as a short startup thing. Then it's the managed one, which will launch a new process, but it's running on the same machine as the test case. Or it's the remote version of it, which can connect to any container being assumed it's already running somewhere.
So the demo time.
Demo time.
Showing code on the slides is cheap, right? So show something live. So the beauty of this test is actually there is no notion about the target container at all. The only thing which you see is that we run with, I maybe switch to presentation mode. It's going to be a bit easier. So the only thing you see is that we want the JUnit to use Arquillian runner, but other than that, it's just code, right? So it's also pretty interesting when it comes to testing against some embedded containers where you will most likely gain some time, or if you want to migrate your application to the newer version of your server, you pretty much change the container adapter and you can verify if stuff is falling apart or it's still working as specification suggests, right? These additional comments are actually for the ASCII doc, so we don't put the code on the slides, it's automatically taken, that's why there's a bit of noise in the samples. Yeah, so let's just try to run it, and we will see what's going to happen. So we are running with Whitefly in the managed mode, which means that Arquillian takes care of the whole life cycle. So it will start the server, it will run the test, and it will collect the results, undeploy, and then stop the server for us. Whereas in contrary to remote, we only deploy and undeploy, and the server still keeps running. So that's pretty much it. I mean, the test has no noise in it. You don't see any kind of bootstrap container, yada, yada, yada. You just have simple test, which looks pretty much like a unit test, but it's a bit more powerful. Then we have also the client test, for which I'm using the JAX REST resource. It's pretty much the same service, just delegates to the service we created as a CDI bin. Then the test, as we already have seen on the slides, it's basically using REST assured to interact with the REST API. What I'm gonna do here, I can just log response, for example. Sometimes it's quite handy. So then I just run the test straight from my IDE.
That's just a normal run with JUnit. There's nothing. There's no extra plugins or anything for it to run.
That's pretty much it. Don't see the logs though, but yeah. Ah yeah, there are. A bit of a demo guts effect. Okay, so that was the simple test, right? Let's have a look at something which is a bit more sophisticated. But before we do it, just a recap of the principles.
Right. So one of the core principles of Arquillian is to provide portable tests. So not to necessarily bind a specific test to a specific container, but try to be able to allow you to run the different tests on the different environments, that being a Wildfly server or a Glassfish server or a server on your own machine versus one in the cloud and so on, and try to abstract all of those different setups and life cycles and so on out from your actual tests and leave the test code as concise to the test that it can be. And yeah, as we were saying, it's a testing platform. There's nothing. Arquillian is not a JUnit extension per se. That's just one of the possible entry points to it. There's probably 40 different extensions at this point to kind of hook into the different Arquillian things to give you more testing-related services or help you bundle up specific things or control other types of services for you. Things like Selenium or WebDriver setups. We'll see some help with persistence, for instance. We'll see some examples of that. And the newest member in that family is, of course, what we're going to talk about today.
Yeah. So, yeah, that's right. I got a bit off the track. So yeah, the newest extension in the universe is called Arquillian Cube, which pretty much is the main topic of this talk when it comes to testing microservices. So we're going to start with a bit of an overview what it does. Arquillian Cube is responsible for managing the lifecycle of Docker containers. So it will start defined images. It will do all the heavy work for Docker containers so that your test can actually use them. And the cool stuff is that you will be able just to run it straight from your IDE like a regular test, and everything will be taken care of. When it comes to using application containers such as Wildfly or JBoss application server or Tommy, you name it, then obviously we need to connect somehow to this running server, and for this purpose we use the remote adapters. So this third kind of adapters we have, which effectively means that we will just deploy things. But on the other hand, Cube will take care of shutting down all this stuff when we finish all our test executions. And in addition, it also lets you orchestrate the containers, meaning that you can define, for example, as we will see later on, that you want to have a container with Wildfly and you want to have a container with MySQL, and they need to be linked together, so it will be all started and then your test will be executed. And the last part, maybe it's not actually for Cube per se, but in general, Arquillian and Arquillian Cube, they are not only for application servers. You can use whatever kind of technology you like. You can use Drop Wizard, Spring Boot, Netty, Node, VertX, weapon of choice, polyglot microservices, right? Okay, but we'll start with something very simple. We will have a simple JPA repository, which, as you probably will notice, is based on our favorite drink. What we will use is JBoss, official JBoss Wi-Fi image. However, we need to add just a few small things in order to make it running, which is adding the user and the password so that we can log in to the remote server, and then basically say Docker to start the container with this given setting so it will be reachable from the host. But that's pretty much it. So then the test itself looks almost like a unit test, so I skipped a bit of lines here for the sake of simplicity. With regards to deployment, you can obviously use shrink-wrap Fluent API to create your packages, but you can also just grab arbitrary existing EAR file, for example, and just deploy it. There's nothing which enforces you to explicitly use shrink-wrap API to bundle your deployments, even though it's very handy because it lets you think about how your packages are, how your components are structured. If you need to write too much code, then it means that probably it's not a microservice and there is some other stuff needs your attention in your code base. So then what we do, we inject the beer repository. This tiny little annotation here, that's Arquillian persistent extension, which if you heard about unitils, for example, or there is also Spring DB unit, it's pretty much similar concept. So you externalize your data definition to data sets which are handled by DB unit. In addition, we have YAML, which DB unit does not provide by default. And then what will happen is that before the test, this will be taken and it will sit the DB. Then your test will start with having the access to the data, and at the end it will clean it up. There are also some additional features in this extension, but they are not really that relevant for the moment. So the test itself will basically check if the pretty cool criteria API from JPA, which I wrote, is correct. We're going to be looking for the strongest beer in the world, which is actually outdated now. So simple dependencies this time. We're going to need to add kube Docker and remote container for Wi-Fi. And then this is your Docker container definition, where we say we use Wi-Fi using this particular image stored in this folder, and then we just expose the ports. And you can see that actually you don't really need to configure Wi-Fi with the ports we have set, because that's automatically given from kube, so there is no need of setting it up explicitly. And that's time for the demo then. That's demo 3. Toggle the presentation mode again. Okay, that wasn't this. Again. Toggle presentation mode. Okay, so this is the test. It's, as you can see, has a bit more stuff than normally, but it's still pretty brief. Then this is the Wi-Fi image, which we mentioned before. And this is the whole configuration, and that's pretty much it. Let's see what's going on when we run the test. So I have a bunch of other tests here. You see that at this moment there should be Wi-Fi showing up, hopefully. Oh, not really. Demo guts. What's this? Any questions so far, so I can handle this quickly? Right. It cannot start because yeah, I didn't kill my super cool web server, so I need to do it. Docker, yeah. I ran it like 4 times this morning, so I hope it won't fail me again. All right. So now it's disappeared. Let's give it another try. Okay, great stuff. Now it's probably something, yeah, conflict, okay. But this I know how to fix. You basically do Docker, remove this, and then it should be all good, hopefully. Okay, I think I didn't have any coffee today. That's the main problem. Oh my God. Okay, give me one more try, please. Okay. I will probably need to.
Look at if you go to Docker PSA.
Docker PSA.
Oh, yeah.
Okay, it started. Yeah, that's probably the. Yeah, let me just kill it once again. At least you can see how you can easily kill and spawn Docker containers. As simple as that. One more time.
You need to remove the image as well, wouldn't you?
No,
Yeah,
really?
yeah.
Yeah. Okay. We are getting there.
Contact with naming, and yeah.
Yeah.
You got to kill it, and then you got to
Okay, so.
RM the container as well.
Okay, but okay, I didn't kill it, right? I just shut it down. Sloppy programmers. Okay, now it's. Yay! All right. Thank you very much for staying with me. You can see what's going on underneath. You can see hook into the Docker container and see all the logs. And I should have a green bar by now. Great.
A couple of them as well.
Was that?
Oh, it's a couple of them, aren't they? A bunch of them, green bars.
Yeah, a bunch of them. Cool. The YAML file is pretty simple. Let's give you a quick stuff. You just have, it's DB unit underneath, so it's oriented towards a database schema, which is maybe not so great, but it's not really that bad anyway. So you just define how your content should look like. There are tools which let you export DB content straight to the DB unit formats. I think Jailer is one of them, and it gives you XML, which probably is not the best, but we can live with that, I guess. And that was it for my part, and hopefully your part will not be failing, because I cleaned everything.
I hope so. So orchestration in Docker, well, Cube is generally just using the standard linking of Docker containers that comes with Docker itself. But we also support then not just necessarily having the application server or a single Docker image controlled by Cube at once, but you can have multiple and link them together. So for instance, in our example here, we're going to be running a Wildfly container that's going to also start up through the Cube's auto startup feature, start up a MySQL database. And right, yeah, what do you say about that? So generally, the Cube format that's in this file is essentially exposing what Docker supports itself. So in the, let's see, where do we have that thingamajig? There we go. So we're defining a Wildfly image, same as we've been doing before. And we have a MySQL image. Oh yeah, okay, yeah, right. So a MySQL image. And then the Wildfly container is linking to that MySQL image. And we're defining that Cube is going to auto start up the MySQL image, as opposed to the container, which is going to follow the normal container lifecycle within Arquillian itself. So it will be started as a part of the suite or the class and so on, depending on how you configured it. But the MySQL image will at least start up. And so now you have two Docker containers to work with, one that will communicate with the other. One thing to note here is that the Wildfly MySQL latest image is using a feature within Cube to extend the other image, which allows you to have like a base image if you have multiple different setups and just extend them to just override a single thing. So if we use the Wildfly image, we would just start up a standard Wildfly container, but with the extending Wildfly, we can also add extra link. So technically here we can either go against the built-in database that is in, or the, what is it? HSQLDB that is built into Wildfly, or we can start up a different image where actually the database is external. Similar, do we have an example of that later? Where we do that? Yeah, we'll do that.
Two different databases? Yeah, we do.
Yeah. So that's the extensibility. So
let's show it. Hopefully this will work this time. Okay, so this is demo 4. what I have here is exactly what Aslak just mentioned. The test is pretty much the same as before. The addition here is the deployment of the data source, because we need to have data source registered before we actually can start our application. Obviously, we can do it in several different ways. We can actually just extend Docker file and configure it using the Wi-Fi command line tool. But just for the sake of the example and to show you a bit more about Arquillian Cube and linking stuff, I decided to create the deployment here. So as you can see, there are two deployments where I also define the order. You can actually use shrink wrap Maven resolver, which can resolve the dependencies on the fly for you. Maybe not the fastest way, but at least if you have more complex setup, it does the job of taking all the compile scope dependencies and so on. The MySQL data source is Java EE7 edition, I guess. And that's just a simple startup singleton bean which defines the data source. As you can see, this is how I refer to my MySQL database, which is exactly the same as the one in the links, where I just give it an alias and then it's recognized by the Docker container that it's available, and I don't need to expose the ports because I actually link the containers so they see each other, and there is no need of going over the host back to the container and so on. There are a few other things which are cool about Docker that are quite easy for such a setup, is that you can actually create the DB on the fly with your user, password, and so on. But let's just run the test now. So we will see what's going on underneath. I will just run Docker PS to be sure that nothing else is hijacking my presentation. Okay, let's run it.
So first here, Cube is going to start up the auto start defined container, which will be the MySQL one.
So both are already up and running. We can now pick the Wi-Fi logs. Oh yeah, this is Wi-Fi MySQL latest. You see that the data source was already registered, and now we start our application. There will be some hibernate log because the DB is empty, so it cannot drop, but it still creates the schema. And then I think we are done with the example here. Is it the right one? Yes, we have a green bar. So that's pretty much easy. The cool thing about it is for the persistent extension, which I'm the main culprit, let's say, or the guy who is messing around with this code too much, is that I need to test it against several different databases. So what I was doing before I learned about Docker, I had Postgres, MySQL, and then I had the Oracle VM with Oracle DB. I had MS SQL VM with Windows, which I still have because that's not really possible with Docker as of yet. But now, what I did, I changed to Docker containers. So first of all, it's significantly faster because I don't need to boot up the whole virtual machine, which is essentially operating system with hardware emulation and so on. I can just, by using simple properties, I can just run the tests against Docker containers, and actually I can also run against several different MySQL versions. So when somebody will report a bug that some SQL scripts, for example, are not working in MySQL 5540, then I just, by switching the property, I can verify if the bug can be reproducible on my machine. And I can actually probably show you this demo live. I have a tiny little alias here. Okay, I need to go to demo 4 and then I run it. So basically what it does, it passes the property MySQL 5.5, which you see in here. So either if it's defined, or if not, by default take the latest, and then the whitefly container is basically getting the value as well. So I don't need to configure way more than I actually have with the Docker setup. And this hopefully will work. So now I run it from Maven. You see the MySQL is started. It's actually MySQL 5.5. Whitefly is started. Tests are hopefully running. And I didn't need to change anything in the test code. I didn't need to change anything in the data source. And just by swapping the property with Docker images, I can run it against older version of MySQL. And that's, for me at least, in my use case, is pretty impressive.
Similarly as well, you can imagine if your application, if the application that you have has a requirement to support older versions of your database schema or so on, creating Docker instances that has all of those different versions and running the test code on top of them, but just starting the different Docker containers would be a fairly easy setup as well.
If anyone tried Node on Ubuntu, trying to change it even with NVM is a bit of a pain. So actually Node containers, I mean Docker Node containers are super good for building stuff against different versions of Node. Okay, which leads us to the last part of the presentation, which is what we call containerless. If somebody else will have a better name for this part, we can have some swags afterwards.
Right.
So basically what it is we can use Cube to deploy any application to the Docker container and then run black box tests using Arquillian. So yeah, as we mentioned before, there are a bunch of interesting technologies you can investigate for building microservices. For example, Drop Wizard, Netty, Node, Spring Boot, VertX, or the new kit in the Whitefly family, which is Whitefly Swarm, which is pretty similar to Spring Boot, I guess, conceptually. But for this given presentation, we're going to show you some simple Node application. So what we have here is another dependency which you need to use instead of the Docker or yeah, that was just Docker, right? So this is called Containerless, and then the definition is like we had before. So we have Docker containers where we build Node from the given image, and we just expose it to the host so that we can connect from our IDE. The important thing is that we should define the name of our image to be started for this given container adapter, which is containerless. Then the application looks pretty simple. So the Docker file template is pretty much Docker file, except of this tiny little property. This is the name of the artifact we're gonna build using shrink wrap. And this will be, it's a tar file, which will be automatically replaced during start of Cube. Basically, we don't use copy, we use add, because add will on the fly untar the archive and put it to the container. So that's one of the differences between copy and add in Docker. And then what we do, we just download the whole internet using npm install, and then we expose 8580, and we say when the container starts, run npm start within the work directory. What's that?
We have 5 minutes.
Okay. So that's the application. It's an Express.js application, which is actually a better version of the strongest beer I've shown you before. This is the current winner, 67.5%. Yeah, I mean, for the sake of the demo, that's just a simple application, let's say, but that's not really the core thing for this presentation. So the test, again, we are dinosaurs, so we write it in Java. We deploy generic archive, which is a tar archive, just with the two files. So our application, which you have seen in the previous slide, and then dependency for Express, and probably tons of other things. And then we use Rest Assured, which I highly recommend for testing, or not only testing, because you can use it as a client as well, for testing REST resources. And that's all the magic. We get the URL dynamically from from the Docker Cube, and this stuff should run, hopefully.
So in the other demos, we were showing where you were actually just running Wildfly within a Docker image and using it as a normal application server where you're actually connecting to the management ports and deploying it and so on. In this case, it's the pre-packaged or pre-prepared image. And even with Wildfly, you can use the containerless container to add the deployment to the deployment folder, essentially. So it's a complete image that you have done that is prepared with all the tests and so on and can be reused as opposed to.
So that's the application. This is the test we were talking about. And this guy will be replaced exactly here on this line so that we can see the real content be deployed on the Node container. So let's give it a try. I tried to run it. So you see on the Docker PS, there is a container.
It's done.
It's done. Okay, I was too slow.
Oh, no, it comes there.
Okay, so it started the Node app, and I think we are pretty much done. So that should, yeah. Then now it's all cleaned up. I mean, it obviously takes a while because it needs to start all the containers and stop it afterwards. But other than that, it's fairly simple.
2 minutes.
2 minutes. So yeah, we have 2 minutes left, and we only have a bunch of things to share what's coming next.
So Cube is still in its release now in Alpha 5. Alpha 6 is coming tomorrow or so. Currently, it's only Docker. OpenShift version 3 support comes in the Alpha 6 version. We're also investigating reusing the Cube structure, so to speak, to also support for CoreOS and Docker Composer, Docker Machine, and Mesos to be. So Cube will be the whatever Docker thing.
Swiss Army knife for containers.
Right.
Okay, and that's pretty much it. Thank you very much for staying with us. These are the main coordinates, so arquillian.org or discus.arquillian.org. So the first is all the resources you might find useful. The other one is just the developers forum. And we are on GitHub, obviously. And these slides we're going to push later today.
Is your demo code going to be pushed?
Yeah.
Sorry?
Your demo code, will that be available?
Yeah, everything is within the same repo. The only thing I need to sort out is the pictures for which I have a license and I don't want to make them public. You know? But I paid for them. Okay, any questions? Or we can handle it afterwards, I guess.
Yeah, one of the pretty cool things I found when using Arquillian was when using it in combination with ByteMap. Is that also supported through the Arquillian Cube?
It should be, yeah.
So the question was if
Right.
we can use Arquillian Byteman, which lets you inject bytecode to your application, so you can do a fault injection and verify if your application runs, how your application behaves when stuff happens unexpectedly. So yes, it works with Cube, because pretty much that's only the additional layer of indirection, nothing more than that.
Yeah. So technically, most things that work with Arquillian should work on Cube as well without any problem.
Okay.
That's the power of APIs, I guess, or something.
Magic.
Magic. Yeah.
Okay, thank you very much.
Thank you.
Enjoy the rest of the conference.